you had a great week. Today we'll be going over Chapter 11, End of Chapter Questions, and discussing the t-test for repeated measures research design. The primary difference between the t-test for repeated measures research design and a t-test for an independent measures research design is that instead of looking at raw scores, we're going to be doing a t-test that is based on the difference of two scores. In a repeated measure study, we have one group of people and we're taking scores twice, so we're repeating the measure. This is slightly different than an independent measures research design, where there are two different populations or two different treatment conditions. Here we just have one, and we have two different measurements for the same group of people. In our first example question, we have an N of 16 with a mean of different scores of 3.5 and a sum of squared deviations of 135. First, we can find our variance with the sum of squared deviations divided by n minus 1, which gives us a variance of 9. Then we'll use the variance to find the estimated standard error by taking the square root of the variance divided by n. In this case, we have a standard error of 0.75. Next, we'll find our t-value by taking our mean for sample of difference scores minus the population mean, which is going to be 0, and dividing that by the estimated standard error. We get a t-value of 4.67. Next, we have to determine whether that t-value is significant or not. So we'll move our slider for our degrees of freedom to 15 and move the other sliders to where there's 0.025 tails on either side of the body. And we'll find that our critical region for t is plus or minus 2.131. If we visualize our t-value, which is in the far right tail at 4.67, we'll see that our value is significant, and we will reject the null because humor does have a significant effect on memory. On our next question, we are given several data points from participants before and after treatment, and we are asked to calculate the difference scores and the mean for the sample of different scores. To find our difference scores, we're going to have to take our after treatment score and subtract our before treatment score. We'll perform this calculation for each score, then add them all up to find the sum of different scores. Then we'll square each different score and add them up to get the sum of different squared. And we'll use the sum of the different scores and the sum of the squares of the different scores to find the sum of squared deviations for the sample of d scores. We'll take the sum of the squared differences and subtract the sum of the differences squared divided by n, and we'll come up with a value of 6. Next, we'll use the sum of squared deviation for the sample of d scores to find the sample variance, which is the sum of squares divided by degrees of freedom, and in this case is 2. And we'll use our sample variance to determine our estimated standard error, which is the square root of the variance divided by n. And in this example, we have a standard error of 0.707. Now we'll find our mean for the sample of different scores by taking the sum of different scores divided by n, and in this case is -3. Then we can find our t-value, which is our mean divided by the standard error. We'll come up with a value of 4.24. In order to determine whether that is significant or not, we'll find our critical t value by moving our degrees of freedom slider to 3 and moving the t sliders to where there's 0.0050 in each tail and 99% of the scores are in the body. And we'll find that our critical t value is 5.841. Since RT is 4.24 and is inside the body, we'll fail to reject the null because there is no significant effect. In our next question, we're given a research of a matched subject's design, where even though there are two individuals, the matching is done so that the two individuals are equivalent or nearly equivalent with respect to the specific variable that we're wanting to control. So to find our difference score, we're going to take our change section and subtract our no change section. And we'll do this on down for each set of matched pairs. Then we'll take our difference scores and add them up to find the sum of difference scores. Our mean for this sample of difference scores will be the sum of difference scores divided by n. And that gives us a mean of 7. Next, we're going to square each of our individual difference scores, and then we'll add them all up to find the sum of our squared differences, which in this case is 729. Then we can use our sum of differences and our sum of squared differences to find the sum of squared deviations for this sample of D scores. We'll take the sum of squared differences and subtract the sum of differences squared divided by n. In this case, we get a value of 288. Then we can find our sample variance by taking our sum of squared deviations and dividing it by the degrees of freedom, which is 36. The standard error is the square root of the variance divided by n, in this case is 2, and that will allow us to calculate our t value of 3.5. Our critical t with an alpha of 0.05, degrees of freedom of 8, which gives us 0.025 in each tail and 95% in the body, gives us a value of 2.306. And since our t value is well in the tail, we're going to reject the null because rethinking and changing answers on an exam has a significant effect. Now we're asked to construct a 95% confidence interval to estimate the size of the population mean difference. We already know that a two-tailed test with an alpha level of 0.05, our t level will be 2.306. So we'll take that t and multiply it by our standard error, and we'll add or subtract that number to our sample mean. Since the confidence interval is the upper and lower bounds of the estimate that you'd find at a given level of confidence, we would explain this by saying that the 95% confidence interval extends from the lower bounds of 2.388 to the upper bounds of 11.612. This means that 95% of the scores will be between those two numbers. Our next example question is using a repeated measures research study, that is studying whether swearing can help reduce pain. We are given the amount of time in seconds that each participant was able to keep their hand in icy water while verbalizing swear words versus verbalizing neutral words. It is suggested that a person using swear words will be able to hold their hand in the icy water for a longer amount of time, thus demonstrating a higher pain tolerance. In order to tell if this is true, we're going to have to find the difference values between these two scores. We'll take the second score and subtract the first score, which gives us a direction of change, so a negative value versus a positive value, so we know whether the score went up or down. We will repeat this calculation with each participant and log their different score. And we'll add all of the different scores together to find our sum of different scores. In this case is negative 140. Our mean difference will be our sum of different scores divided by n, which is 14. Next, we'll square each different score and add them up to come up with our sum of squared differences. We'll use both of these numbers to find our sum of squared deviation for the sample of D scores, which is the sum of squared differences minus the sum of differences squared divided by n. And in this case is 1,152. Our variance is the sum of squared deviations divided by degrees of freedom, which is n minus 1. And our estimated standard error is the square root of the variance divided by n, which equals 3.58. Now we can find our t-value, which is the mean difference divided by our standard error, which equals 3.91. In order to determine whether our t-value is significant, we have to identify our critical region by moving our degrees of freedom slider over to n minus 1, which is 9, and sliding our regions to where we have 0.025 in either tail for a two-tail test with an alpha level of 0.05. We'll find that our t-critical is 2.262. We'll use this information to reject the null because our t-value is in the tail, which would indicate that using swearing words does in fact have a significant effect on pain tolerance. Then we're asked to measure the size of the treatment effect by computing R squared, the percentage of variance accounted for. The formula for R squared is t squared divided by the sum of t squared plus degrees of freedom. In this case, we have a value of 0.629. Well, that's about it for this week. I hope going over these example problems helps you on your own calculations for Chapter 11 end of chapter problems. Have a great week, and I'll see you next time. Take care.